Ever tried following a recipe, only to realize you used salt instead of sugar? Or maybe you're booking a hotel, but the system keeps crashing. These little hiccups might seem minor, but for AI models, like the ones powering your favorite apps, they're massive challenges. Today, we're diving into a groundbreaking study that's redefining how we evaluate AI's ability to handle errors. Let's break it down. Here's the thing, large language models, LLMs, are incredibly powerful. They can write essays, code, even help plan a trip. But here's the catch. They rely on external tools like APIs or databases to perform complex tasks. Think of these tools as kitchen gadgets. The problem? When things go wrong, like a broken blender or a missing ingredient, the AI needs to detect the error, diagnose it, and fix it. But most existing tests don't measure this. They just check if the AI gets the right answer, not how it handles mistakes along the way. Enter CRITIC TOOL, a new benchmark designed to fix this gap. Imagine a comprehensive test that throws everything but the kitchen sink at AI models, forcing them to grapple with real-world errors. The goal? To see if these models can self-criticize, recognize their own mistakes, and adapt. How did they do it? The team analyzed thousands of tool-calling scenarios, like booking a hotel or searching the web. They identified 5 core error types. 1. Tool selection errors, using the wrong tool, like a spatula instead of a whisk. 2. Parameter mistakes, inputting 7:00 p.m. instead of 19:00. 3. Environment issues, like a server crash. 4. Hallucinations, making up fake tool responses. 5. Repeated failures, trying the same thing over and over. They built a dataset using an evolutionary strategy, creating scenarios that escalate in complexity. Think of it as a training ground where AI models face increasingly tricky challenges, learning to recover from mistakes. The results? Surprising. Even top models like GPT-4o and Qwen2.5-72B struggled. For example, GPT-4o succeeded in just 22% of environment errors, while Qwen Turbo fared worse. But here's the kicker. The study didn't just measure success rates. It revealed that models handle errors in unique ways. Some double-check their steps, others give up early, like a human might have stuck. Why does this matter? As AI takes on critical tasks, like medical diagnoses or financial planning, we need models that can adapt when things go wrong. But how do AI systems improve? Let's break down a study that's making AI smarter, more reliable, and better at fixing its own mistakes. Think of it as giving AI a toolkit for problem-solving, so it doesn't just guess but learns from errors. Here's the problem. AI tools often interact with real-world systems, booking tickets, checking the weather, or even coding. But when they mess up, how do they know they're wrong? That's where this research steps in. The team used a clever approach called mixed evolution. Instead of one method, the AI randomly tries 2-4 strategies to solve a task. Imagine a chef testing multiple recipes to perfect a dish. Sometimes the first attempt fails, but the next works. This randomness helps AI handle messy inputs, like typos or unclear requests. But how do they verify accuracy? They use GPT-4o to validate results, like having a second expert double-check work. The process is visualized in data evolution charts, showing how the AI refines its thinking step by step. The real magic. A framework called CRITIC TOOL that measures 4 key skills. 1. Reflect, can the AI spot its own mistakes? Like catching a typo. 2. Correct, can it fix errors? Editing a draft to make it perfect. 3. Retry, if a tool fails, does it try a different approach? 4. Skip finish, does it know when to move on or wrap up? Take booking a movie ticket for Big Fish at the Golden Cinema. The AI might check details, confirm the time, and process the booking. But if it misreads the time or misses a step, the evaluation metrics flag and correct the error. What's the big takeaway? This research shows how AI can become more adaptive and resilient by combining strategies, verifying results, and learning from mistakes. It's like giving AI a superpower, the ability to think, adjust, and improve, just like humans do. Thanks for watching. If you're curious about how AI learns and improves, hit subscribe for more deep dives into cutting-edge research. And let me know in the comments, what's one task you'd love to see AI master? Until next time, keep exploring. So here's the big question. How should AI handle situations with no clear right answer? Think about it, when we humans face ambiguity, we use context, experience, and even guesswork. But for AI, ambiguity is like a puzzle with missing pieces. Researchers are asking, how do we teach machines to navigate uncertainty without crashing into dead ends? This isn't just theoretical. Imagine an AI doctor diagnosing a patient with rare symptoms, or a self-driving car deciding between 2 risky maneuvers. The stakes are real. The CRITIC TOOL benchmark we discussed earlier is one way scientists are testing whether AI systems can learn from their own confusion, like a student who realizes they don't understand a concept and then seeks help. But here's the twist. There's no single correct answer in ambiguous scenarios. That's why the research community is buzzing about new methods, like training AI to ask questions or evaluate multiple possibilities instead of defaulting to guesswork. The goal? Systems that don't just process data, but think critically about what they don't know. So what do you think? Should AI prioritize caution, creativity, or something else when faced with uncertainty? Drop your thoughts below, let's spark a conversation. And if you want to dive deeper into how AI evolves from mistakes to mastery, hit that subscribe button. Because the future isn't just about smart machines, it's about machines that grow smarter every day.